Welcome, GeoTrig. This is section 6-4, properties of rhombuses, rectangles, and squares. The essential question is, what are properties of the diagonals of special parallelograms, rhombuses, and rectangles? Let's begin. So here's a few definitions just to remind you what these shapes are. A rhombus is a parallelogram with four congruent sides. Boom, 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 boom. A rectangle is a parallelogram with four right angles. So boom, 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 boom. And a square is a parallelogram with four congruent sides and four right triangles. Just like this. So kind of a combination. If I write this as a Venn diagram, this is what it'd look like. You got rhombuses here, rectangles here, and squares in the middle. If I want to do an overall here, oops, bad at drawing. An overall circle surrounding this, parallelograms would cover everything. So yeah, these are all different types of parallelograms, and in the parallelograms Venn circle. So here's some theorems on rhombuses. So if theorem number one, if a parallelogram is a rhombus, then its diagonals are perpendicular. So you got a rhombus here, then you got two diagonal lines going from AC, BD. Those lines are perpendicular. And if you want to learn the proof of that, it's the perpendicular bisectors theorem from section 5.4. Go ahead and review that, and you would get the proof. Another theorem for this: if parallelogram is a rhombus, and each diagonal bisects a pair of opposite angles. So you got opposite angles right here, boom, and it's bisecting these same pairs of opposite angles. A and C are opposite, and those are both being bisected. If you want a proof for this, you have two triangles ABC and CDB right here. Those would be congruent by side, 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 and then you could look at corresponding parts. Now for our theorems for rectangles, we got one. So if parallelogram is a rectangle, then its diagonals are congruent. So diagonals AC and BD are congruent. And why does that work out? Well, you got two triangles here, ABC and DCB are going to be congruent triangles, and then the corresponding parts would be congruent, and you can prove that. So that's it for this section. Let's try some examples. So pause the video. All right, what are the measures of the numbered angles in the rhombus PQRS? So I got this angle Q is going to be 104, so I got to figure out measure of angle 1, and that's going to be, well, let's see. You know that this is being bisected right here. So measure of angle 1 is going to have to equal the measure of angle 2. And measure of angle 3 is going to have to equal the measure of angle 4. And actually, they're all going to equal each other anyways. So it's going to equal the measure of angle 3, which equals the measure of angle 4. That's what we learned just on one of the rhombus slides. So in this case, if this angle is 104 and angle 1 and angle 3 have to be the same, then I know the equation for this is 180 minus 104 is going to have to equal the measure of angle 1 plus the measure of angle 3. So, and they're both going to be the same, so that's going to be, what, 76 equals both those measures. So 76 divided by 2 is going to be 38. So measure of angle 1 is going to equal 38, and that means everything equals 38. Next one. Pause the video. In the rectangle RSBF, SF equals 2x plus 15, and RB equals 5x minus 12. What's the length of diagonal? Well, we know this is a rectangle, and we know from that theorem right there, all the diagonals are congruent. So if that and that diagonal have to be congruent, so I can set those equations equal to each other. 2x plus 15 equals 5x minus 12. So let's solve for x. I subtract 2x on both sides, I get 3x minus 12 equals 15. Add 12 to both sides, and what I'm going to get is 27 equals 3x, divide by 3, and x equals 9. So if x equals 9, that's not my answer. I've got to actually find a length of one diagonal, so I'll plug it in. And let's see, I'll just plug it into this first one, 2x plus 15. So it'll be 2 times 9 plus 15. So 18 plus 15, and that's going to be 33. So my answer is D, 33. That's it.